Multilayer perceptron is a classic feed-forward artificial neural network. It is one of the core component of some deep learning algorithms. Not all algorithms in deep learning use a feed-forward artificial neural network, but many do. Another way to look at this is that a multilayer perceptron is a connected series of nodes, where each node represents a function. This connected series of nodes create what is called a directed acyclic graph, meaning that there is directionality between the nodes and no node will ever be revisited. This all starts with an input layer. Let's use the Titanic dataset example. There are 4 nodes here, and each node would represent a feature that we want to use to predict whether somebody survives or not. These could be age, ticket class, cabin, and sex. Next, there's a hidden layer that we're representing with 5 nodes here. But this hidden layer could contain 10 nodes, 100 nodes, or even 1,000 nodes. Now each of these nodes represents some function. What happens is, we take each of our input nodes, representing features, and we pipe those into each node in the hidden layer. What's happening here is each node, or function, in the hidden layer is getting each input feature. So age, ticket class, cabin, and sex are passed into each node in the hidden layer. You could view each of these nodes as something like logistic regression. So, more or less, a logistic regression model would be fit for each node made with slightly different weights. Then we have an output layer. And here we're going to have 2 nodes. Either a person survived, or they did not survive, using the example of our Titanic dataset. Now we have each node in the hidden layer, outputting to each node in the output layer. Let's take a step back and just isolate one node in the hidden layer to understand what's happening here. You can see it's receiving the 4 inputs. Then this one node in the hidden layer will basically fit some model, or learn some aspect of the data. Then based on that model that it learns, it'll make some prediction about whether somebody survived or not. Maybe it's 70% likelihood that they survived, 30% likelihood that they did not. That's just one individual node in the hidden layer. The same process can repeat for each of the 5 nodes in the hidden layer, and you get a final prediction of the likelihood of a given person surviving. As you can imagine, these can be incredibly powerful. As you see in this example, you're essentially aggregating the predictions of 5 different models all together. This allows the overall model to learn some really powerful relationships in the data. When should you consider using a multi-layer perceptron? Up to this point, we've suggested using logistic regression and SVM only for a categorical or binary target variable. One nice aspect of multi-layer perceptrons is that they're really powerful for both classification and regression. In other words, they're useful for both categorical and continuous target variables. As mentioned earlier, the way multi-layer perceptrons are constructed allow them to learn very complex relationships in the data. If you have complex relationships in your data, or all you care about is performance, and you don't care about training time or interpretability, then this might be a good tool for your problem. There are a lot of hyperparameters to tune. If you want to have a lot of control over the training process, multi-layer perceptrons might be a good method to explore. When should you not use it? Multi-layer perceptrons are a core component of deep learning. You may have also heard that deep learning is really good for tasks like image recognition or time series. That does not mean that multi-layer perceptrons are good for these kinds of problems. There are specific algorithms within deep learning, like convolutional neural networks, that are very good for image recognition. So, you should not use multi-layer perceptrons for this kind of work. If you care about transparency or significance of predictors, you also shouldn't use multi-layer perceptrons. They're kind of like black boxes. You pass in inputs and it returns predictions, and it's quite difficult to understand what's going on internally that is generating those given predictions for any model. This is another algorithm just like SVM that isn't great for a quick benchmark model. Multi-layer perceptrons require more hyperparameter tuning than some other algorithms, so you need to spend time doing that before you can expect to get a good model. It can also take a while to train, though not quite as long as SVM. So, this isn't a great choice as a quick benchmark model. Lastly, you should not use multi-layer perceptrons if you have very limited data available. They really thrive when you have a lot of data. If you don't have a lot of data, you're probably better off exploring other options as the time investment likely won't pay off in performance. For instance, you might be better off with SVM or logistic regression when you have limited data. In summary, multilayer perceptrons are often the best tool for the job when you have a lot of data and you really only care about performance. But they're not ideal if you have limited data, if you don't have much time or compute power, or you really care about the transparency of the model and understanding its predictions.